I'm Dr. T. Welcome to my office. So today I'd like to talk about the rocks in space. And of course that means I'm going to be talking about the inner planets. So of course we've got our solar system. In the middle, containing virtually all of the mass, is the sun. It's a nice great big star giving off lots of useful energy, as well as some not so useful radiation, but we got a magnetic field so that things will work well. Anyways, so the inner planets, these are going to be the rocky planets, are going to start out with Mercury, which is a nice barren rock, real close to the sun. Then we got Venus. Now Venus is noteworthy in that it's got lots of CO2 in its atmosphere. It has an atmosphere. So it has a very thick, very high pressure atmosphere, lots of CO2. And even though it is further away from the sun than Mercury, the temperature on Venus is much, much hotter because the heat doesn't escape. It's like super uber greenhouse gas. So it gets ludicrously hot. Although there are people talking about doing manned missions to Venus. And you're like, what? The idea is you would put people in like a floating, Zeppelin-like thing, and fairly high up in the atmosphere. The temperature's not that bad. The gases are toxic, but there's enough pressure you could float. So yeah, that's a plan. So next up, of course, is Earth. We're familiar with Earth. You're going to look out in your backyard and, well, that's Earth. Going after that is kind of the last rocky planet, Mars. Smaller than Earth. It has a very thin atmosphere. That's kind of the classic where to go next. Now, of course, a couple other things on the trip. Earth has a very nice big moon. A moon is going to be a typically rocky body, doesn't actually have to be, that orbits a planet. So it's going to be a natural satellite. There's not a great definition of how big it has to be, but basically something that's orbiting nicely that's not, dust size or small particle size. So we don't consider every single particle in the rings of Saturn to be a moon. You have to be somewhat larger, but we don't have a great definition for moon. There's a couple things we still need to work out the bugs for. Now, going past the orbit of Mars, and kind of the last part we'll do for this particular video, is the asteroid belt. So if you think about kind of size terms, planets are big. They are big enough that they have enough gravity that they have become circular or somewhat spherical. There's a couple of caveats on that, but yeah, they're basically going to be spheres. Because if they weren't, there's enough gravity to pull the parts that we're lumping out in and make them fall down and thus round out the planet. Second, and this is kind of the newer part of the definition, planets have to have enough gravity that anything that was in their orbit either got pulled into the planet or slingshotted away from the planet, so that their orbits are now pretty much clear. Once you go to the asteroid belt, we meet our first dwarf planet. So dwarf planets meet only part of the criteria for being a planet. Dwarf planets are large enough that they've gone spherical, but they're not large enough that their gravity can clean out their orbit by either pulling it in or ejecting it from their orbit one way or another. The dwarf planet living out in the asteroid belt is Cirrus. So we've got planets, we have dwarf planets, and then, of course, we've got asteroids. And asteroids are going to be things small enough that they don't meet either the definition for planet or dwarf planet. So they're too small to be a dwarf planet. But they are still larger than, say, a small stone or a pebble. So these things are at least of some decent size, but they're not necessarily particularly large. And lots of them are fairly small. Now, when you are dealing with the asteroid belt, Hollywood, of course, would imagine you're up to your eyeballs in asteroids. That's not the case. They're pretty far spread out, truth be told. I mean, it's a lot denser than other spots, don't get me wrong, but it's still, mostly empty space. Space is pretty empty. Okay, let's end with a couple other ones. Meteoroids are going to be like asteroids but smaller, so these are kind of small stone-sized things going all the way down into your micrometeoroids. Those are going to be basically sand-size, pebble to sand-size stuff. Actually, I should say those should be sand-sized things and below. And those can actually create a bit of damage for satellites. So those things, you're going quick enough, they can punch a hole, even though they're only sand-sized. A couple other points. Meteor is a asteroid. Well, asteroid, you're having problems, but a meteoroid that's going into the Earth's atmosphere and is currently in the process of burning up in the atmosphere. What happens is, as you have rock slams into the atmosphere, the air cannot get away. It compresses and heats up. That's not actually friction there. There's more going on than just friction. And then a meteorite is one that was large enough that as it traveled through the air, it was not completely vaporized due to the insane heat of it squishing against the atmosphere, and something made it to the ground. At least, naturally doing so. So if you have a rock that was from outer space that did not get a grip on a spaceship of some sort, then that's a meteorite. But meteorites are by definition on Earth. They came from not here, but they're now here, kind of scenario. Okay, next time I'll talk about comets, but for this video, I think we're at a wrap. So I will see you next time with the big balls of gas.